Good evening, my dear friends. How are you doing today? I'm doing good from my end. I'm so happy that you can join us for today's discussion. So, in chemistry, there are a lot of things that we have learned, such as transition methods, which we are told that they are used as catalysts in many of the reactions that they catalyzed. One of them is the Haber process. The other one is hydration, hydrogenation rather, among others. And today, we're going to look at another transition method and how it's used. Okay. Above that, we also have some processes, some reaction schemes rather, that are studied in chemistry, even in science, and these reactions are actually honored by the people who invented such reactions. So today, I want us to look at this reaction, which falls under nine methods, called Oswald process. So Oswald process is a process that is actually used in the manufacture of one of the acids that we know. We also have another process we call the contact process, which is also a process that is used in production of another acid. So in today's reaction, we're going to look at the Oswald process, which is a process that is used to manufacture this common acid we call nitric acid. Nitric acid is a very important acid that we use in industry. It's one of the strong monoatomic, monobasic, or monoprotic acids that we actually have among the acids that have the basicity of one. So in this process, everything that you want to do, every chemical reaction that you want to carry out, there must be things that you need. Those things we may call them raw materials. Even when you're cooking shima, believe you me, you need meal, you need a cooking stick, you need water, you need a source of heat, you need a pot, among others. Those are the things we may call raw materials because they are the ones that actually must be there for the cooking process to be done. So in the Oswald process, the three materials that we need, the raw materials that we actually need, are the ones listed here. You need air. In this air here, all we just want to get is oxygen. Okay, we want to get oxygen from that air. You also need a source of heat. At the beginning, you need the temperature to go as far as 800 degrees centigrade. We also need to have ammonia, not dirty ammonia, but ammonia that is purified. And before you look at ammonia, you should have also learned the process called the Haber process, like I mentioned earlier, because it's a process from which the ammonia is obtained. So those are three raw materials that we actually need. Heat, 800 degrees centigrade. You need air, where we get oxygen. You also need purified ammonia. Now, in as much as we have these three things, it's not, we don't have all these three things added at the same time and they react at the same time. The thing is, this reaction happens stepwisely. So basically, slowly but sure, we're going to run through three steps. Before we do that, please subscribe to my YouTube channel, hit the alarm button so that each time I post something, you're definitely gonna get notifications and then you don't miss any of my pointings, my posts. Now, the three reactions are itemized here, just a summary, but gonna run through them one after the other. So the three steps are: number one, oh no, there's a mixed up. There's a mixed up here. There's a mixed up, but it's okay. It's okay. It's okay. Yeah, it's not even a mixed up. I just wanted to use a low term. It's the oxidation of ammonia. Ammonia actually, as one of the raw material, is gonna react with air. It's gonna react with air. Now, because in that air, like I had mentioned, oxygen is present. So oxygen is gonna be added to ammonia, and some few things will be removed from there. At the end of the day, we're gonna form nitric oxide. We're gonna form nitric oxide. So the nitric oxide, that's nitrogen monoxide. That's what is formed, the first reaction. The second reaction is that very product, the nitric oxide, which is formed, reacts again with oxygen. It gets oxidized. One more oxygen atom is added to form nitrogen dioxide. So here it's actually a monoxide because you only have one oxygen. The second reaction, one more oxygen is added, you're gonna get a dioxide. Once we get the nitrogen dioxide, we can go back to acids and acid bases and salts, where we were actually taught that there are some oxides that are acidic, such as nitrogen trioxide, sulfur dioxide, carbon dioxide, as well as nitrogen dioxide. Why is it an acidic oxide? It's because when it reacts with water, an acid is formed. So we are riding on that property that nitrogen dioxide has. So the third and last step is the absorption of water. So nitrogen dioxide absorbs water within itself, and then the acid is formed. But unfortunately, this process, because water is absorbed, you'll find that this process does not actually produce 100% concentration of nitric acid. We're going to look at that as we go further. Okay, so welcome to my YouTube channel. My name is Mr. Mlenga. Allow me to run you through the steps that are involved in the Oswald process. Step number one. So step number one, we told that oxygen in air reacts with purified ammonia to form nitrogen dioxide. Okay, but this reaction is only possible when oxygen is heated, ammonia is also heated. Together, the temperature slightly goes around 800 degrees centigrade. At that point, when we're gonna have our nitrogen monoxide, which is nitric oxide, formed. Now, this does not happen anywhere. It happens in a chamber called the catalytic chamber. And for that to happen, there must be a catalyst. Remember what I said earlier, that most of the reactions we're going to look at, according to what we were told under transition metals, is that transition metals are used as catalysts. And this catalyst here, PT, is the catalyst that we actually going to use in the Oswald process. So the reaction itself, heat is produced and a lot of heat is lost. A lot of heat is liberated. And then at the end of the day, the heat that remains within this reaction or catalytic chamber is way below 800 degrees centigrade. But at the beginning of it all, in the first step, remember oxygen reacts with the ammonia, the purified ammonia. In the presence of a catalyst, platinum, at 800 degrees centigrade, what is actually formed is nitrogen monoxide, also called nitric oxide, as well as water. So if you actually are to look at the mole ratio, the reaction mole ratio, you need 4 moles of ammonia to react with 5 moles of oxygen to form 4 moles of nitric oxide and 6 moles of water. So this is how best it can help you to balance up a chemical reaction, because according to the law of conservation of matter, at the beginning of a chemical reaction and at the end, the amount of matter must be the same. So let me now show you where this thing happens. So this is actually what we have. So this is a catalytic chamber called platinum agaze. So this is where everything happens. So we have our ammonia pumped in there. We also have oxygen pumped in there. It goes together in there, and then this thing here is heated. And within this, the only thing that we're actually gonna get is the gas. Now remember, this water is a gas, so we also expect it to vaporize. It's not the liquid that one would want to ask, where does the water go? It's also the vapor, so this vapor escapes. Remember, at 800 degrees centigrade, under room temperature and pressure, we expect this water to boil at 100 degrees. But this only happens when the room temperature is, of course, 100 degrees, the temperature of 1 atm. But believe you me, if you have a thermometer right now, try to measure the room temperature around your area, you might actually find that the room temperature is 23 degrees centigrade. So because we are less by 2 degrees to get to 25, you'll find that in most cases, this water boils at a temperature which is 2 degrees less, in most cases 98, 97, 96. It depends on your locality, it depends on your room temperature and pressure. But in most cases where I've carried out this experiment, the boiling point is 97, 97 to 98 degrees centigrade in most cases because of the change in thermodynamic parameters. So that's what happens, the first step. So we understand now at the end of it all, what we obtain is a nitrogen monoxide, which is pumped in the next chamber. So this is also called oxidation because ammonia has gained oxygen to itself, and we can see that this nitrogen contains oxygen. That is the oxidation process that actually was even mentioned. So if we can move on to the second step. Oh, I was too fast. So in the second step, what we are actually starting with is a nitrogen monoxide coming from the catalytic chamber. So like I said, this is monooxide, which we expect to gain another oxygen so that at the end of it all, we're gonna obtain now a dioxide. And this is what has been balanced up down over here. So the second step involves the oxidation. It's the same oxidation process because we only have one oxygen atom seated on a nitric oxide, and here we've actually obtained two. So it's an oxidation process as well. Now remember, the first reaction happened at 800 degrees centigrade, but a lot of heat is liberated, and at the end of the day, the only temperature remaining in this second chamber called the oxidation chamber is around, it's not an exact figure, but around 50 degrees centigrade. 50 or 500, yeah, okay. Now, if you look at what is actually happening in here, is that this is called the oxidation chamber because here at the beginning, the ammonia lost hydrogen in as much as it gained oxygen. But here is a direct addition. We are just adding oxygen, one atom of oxygen to nitric oxide, and purely this is called oxidation as well. So the first chamber, because there was platinum present, that's why we called it catalytic chamber. And the second one, catalytic chamber, also the converter, because we're converting nitric acid, no, we're converting ammonia to nitric acid. And the second chamber, we are just doing the oxidation. So this nitric oxide that came from the catalytic chamber is what is pumped into the second oxidation chamber, in which a mole of oxygen or an atom of oxygen is added to nitric oxide. And at the end of the day, nitrogen dioxide is produced. So we can clearly see that this is an acidic oxide, because this acidic oxide, when under certain conditions, is allowed to react with water. This atom of oxygen is added there. We're gonna have O3. The nitrogen remains. Now, this is a nitrate. This is a nitrate whose valence is Van, charge negative. Therefore, it can only abstract one atom of hydrogen to form this acid called nitric acid. So because the radical that you're going to have there is a nitrate whose valence is 1, therefore this type of acid is going to be a monoprotic acid. Only one hydrogen is going to be present in here. So this is what actually happens in the in the third and last step. So right from this reaction, we can see the arrow shows that we are still going to the third reaction. So here, the only thing that passes over to the next chamber is actually nitrogen dioxide. Okay, so meaning the third chamber or the third step is going to have now the completion of every process. So step number 3, we are saying in the third and last step, still the water is in a vaporized state. The third and last step, warm water is sprinkled, is trickled from the above of this chamber. Now, meaning this is the water that actually reacts with nitrogen dioxide. But in as much as we are doing this, air is still present. So there's a little bit of water, there's a little bit of air that is also present in there. And at the end of the day, that is how the nitric acid is forming. So the third step says nitrogen dioxide formed from the above second step is mixed with oxygen rich air as well as water. It's actually reacting with water in the presence of air, and at the end of the day, the nitric acid is happening, is forming. So that chamber or that tower where it's happening is called absorption tower, because water is being absorbed by the nitrogen dioxide. Simple step, isn't it? So, with your book closed, wherever you're writing, can pause this video and try to go through. So the first one, ammonia, ammonia reacts with the oxygen in air to form monoxide of nitrogen. That's number 1. Number 2, we're gonna react the monoxide of nitrogen monoxide reacts with oxygen to form nitrogen dioxide. Reactions you can do. Third last one. Now the nitrogen dioxide in the presence of air, dioxide in the presence of air reacts with trickled water to form nitric acid. Very simple. So the first reaction happens in the catalytic chamber, in the catalytic chamber. The second one happens in the oxidation chamber, The third and last one actually happens in the absorption chamber. Absorption chamber. Very simple. Now, because the last reaction is actually happening in the presence of water, meaning a lot of water is actually absorbed. And then you will realize that the concentration of the acid, the maximum that you can actually get is the maximum you can get from the Haber process is 68 degrees centigrade. The only time we can get the maximum concentration, it's a strong. Now, I want somebody here to get a clear-cut distinct. There are two things that people don't get it right. One, strong acid. Nitric acid is a very strong acid. So among the strong acids, we might actually have a weak acid and a concentrated acid. Among the strong acids, we might have the weak acid, we might also have the concentrated acid. Then among the strong acid, let me say it again. Among the strong acids, I mix it up. Among the strong acids, we might have the dilute strong acid and concentrated strong acid. And here, among the weak acid, you can actually have the dilute weak acid and concentrated weak acid. So now when we talk about dilute and concentration, we're talking about the presence, the amount of water that is contained in the acid. So because here the reaction itself involves the addition of water. The reaction itself involves the addition of water. That is the reason as to why this acid which is produced is a little bit dilute. It's not 100% concentrated. But even so, even when we obtain this acid at about 50% of water, 50% of the acid, even when we distilled it, we do the simple distillation of this very acid, even fractional distillation, if we can do that, for as long as just a distillation of this acid obtained from here, the maximum you can get is 68. The only time when we can get above 68% of this acid, the only time we can do that is when we do the distillation of this acid in the presence of sulfuric acid. And what is the reason? It is because sulfuric acid is a strong acid. Sulfuric acid is a strong acid. So in the presence of that strong acid, not only strong acid, it also acts as a drying agent. So when we distillate this acid in the presence of strong drying agents such as sulfuric acid, we are likely to go above this concentration to maybe somewhere around 95%. Why is it not possible to get 100%? There's a little bit of high chemistry called eutectic composition. For those who would want to learn more about it, you can actually research. You take tick composition is what inhibits. Composition is what inhibits the obtainment or the possibility of obtaining 100% concentrated of nitric acid. So you need to understand that this process does not obtain 100% of nitric acid, even though heat is involved. Even though we get that acid, we distillate it, we cannot get 100% of the concentration of nitric acid unless we actually involve sulfuric acid. Now, we have the acid. What else are we waiting for? Let's try and see. We have this acid. Where can we use it? We have the acid. Where can we use it? So the uses of the acid is written up here. Oh, okay. I did not include the uses of acids. Let me see it first. Oh, here we are. Okay, so from here, allow me to have a single page sliding in. Oh, okay. So now this is the entire process. We were here, now we actually here. So this is the entire process that we can run through together. So we have nitric acid. No, we have ammonia and oxygen pumped into the catalytic chamber in the presence of platinum at 800 degrees centigrade. Nitric oxide is formed. Nitrogen dioxide is actually formed. After that happens, the nitric oxide is pumped into the oxidation chamber where oxygen is added. The full oxidation of nitric oxide to nitrogen dioxide. The nitrogen dioxide is pumped into the absorption chamber where the nitrogen dioxide reacts with water that is trickled right from the top in the quartz pieces here, in the pieces of quartz here, in the pieces of quartz, and then the reaction actually happens. The nitric acid is obtained right from the bottom. And then the waste gases such as the nitric oxide that did not react, the nitrogen dioxide that did not react, and the water vapor that is coming from here, these are lost as the waste gases. So the reaction for the third and last step is right then over here. Nitrogen dioxide with water, in the presence of water reacting with water, no, nitrogen dioxide in the presence of oxygen in air, reacting with water, and nitric acid is actually formed. So in the reaction mole ratio, we have 4 moles of nitric dioxide, 2 moles of oxygen, 1 mole of water to, no, not 1 mole, supposed because this is 12, so 8, 9, 10, 11, no, yeah, so that's why this is not supposed to be there. This is a sub, this is supposed to show that, yeah. So the reaction is not balanced because we have 2 of oxygen, we have got 4 of oxygen, it's not balanced. And then no, 2 of nitrogen, 4 of nitrogen. So if we had to put a 4 here, we're gonna have 4, 8, plus 8, 16. Yeah, it's not balanced. We'll do the balancing later. Yeah, so this is the overall diagram showing the Oswald process, which happens in 3 phases, in 3 steps. Step number 1, we got step number 2, third and last one, we got a step number 3. So this is what actually happens. Now let's look at the users. So the users, we are saying, oh, it's a little bit of what I talked about, that the nitric acid obtained at the end is only 50% concentrated, meaning 50% of the acid plus 50% of water. This is what we have. It's a 50-50, it's a ratio of 1-to-1 in terms of concentration, the amount of water, and the amount of acid. Even though we do the distillation of this acid, we can never get 100% of the concentration of the acid for the reason I explained earlier, unless we use nitric acid. Unless we use sulfuric acid as a drying agent. We have the nitric acid. Where do we take it? We are saying nitric acid can actually be used in the production of fertilizers, dyes, and plastics. So the nitric acid is used to form ammonium nitrates that are used in formation of plastics, formation of dyes, as well as formation of fertilizers. The second one, there are TNT type of explosions that are actually trending on the market, and what they use is nitric acid. TNT is the type of explosion that are there in the market that we actually make using nitric acid. Third last one is that the nitric acid is actually used as an oxidizer. It's used as an oxidizer in the liquid fueled rockets. So in that rocket fuel, the oxidizer that is actually used is nitric acid. And then the last one, there are those fungal diseases that actually develop on the skin that are called warts. So the removal of these warts, all you need to do is just get a cotton wool, dissolve it a little bit in dilute of the nitric acid, and then you scratch it. You realize that that goes as simple as that. So we actually use nitric acid in the removal of skin warts. Okay, so that is where we're going to end for today. I know it was quite a short presentation, a little bit fast, but it catches more sense. Second time we meet, we're going to look at the contact process where we actually use vanadium pentoxide. We use vanadium pentoxide as the catalyst in the production of sulfuric acid. Now in that process, we are gonna see how 100% concentration of sulfuric acid is actually obtained. So thank you so much. Be on the lookout. My next video is gonna drop anytime soon, but do not forget to subscribe to my YouTube channel. Hit the notification bell so that you don't miss my postings. However, before I say bye-bye, I hate goodbyes, I have a little bit of something to do, which I called Stop and Think. It was an extract from one of the ECZ past papers, which you are actually going to do. Part of it, we've done it. Let me run it through. Nitric acid is an important acid in everyday life. Name the commercial process used to prepare nitric acid. It's already there. State the catalyst used during the commercial preparation of this acid. It's there. The question below shows the initial stage in the industrial preparation of nitric acid. This is what we called catalytic. This happens in a catalytic converter, catalytic chamber. So you just need to copy and balance the equation. It's already up there. Nitrogen monoxide produced as shown by the equation C above reacts with oxygen to give nitrogen dioxide. Construct a balanced chemical equation. It's already up there. How is nitrogen dioxide converted to nitric acid in this process? Everything is in there. Explain why the concentration of nitric acid cannot be made more than 100% if it is distillated. I've already explained. G, explain why higher concentration of nitric acid can only be obtained if it is mixed with concentrated sulfuric acid and desiccated, already explained. Give 2 uses of nitric acid, already explained. So this is the work that I want you to do. Please find the answer and don't be shy to share your findings. Please let them hit my inbox so that we discuss your findings. +2 0975578 So that's a number that you can actually reach me on. If you feel insecure that you cannot hit my inbox that way, please do not be hesitant to email your solutions kunder at 59@gmail.com. Please, I cannot provide a work email, so just that is enough. So thank you so much for watching. Thank you so much for sharing the video. Please share to as many students as you can find. Please, sharing is actually caring. Share the video, share the link, subscribe so that we get to be moving on the same page. Goodbye.